Part 4, gear selection. Well, I made a little mistake when we were breaking in the motor. I said that we were going to use the RPM readings we made at 12 volts. I forgot that the club's Slot.it challenge is raced at 11, so instead of doing a bunch of math, let's just read this motor again after break-in at 11 volts. Okay, so I have my power supply preset. Let me connect my positive and negative here, and let's get it going. Okay, so about 22,000 RPM at 11 volts. Okay. Alright, so 22,000 RPM at 11 volts. Why do I want to know this number? Well, a very well set up car, slotted car on our track, turns very fast laps depending on the diameter of the tire, with RPMs at the wheel ranging from 7,500 to 8,500 RPM. So let's just do our math with the midpoint, which is 8,000 RPM. So if we get 22,000 RPM divided by 8,000, this will give you your initial starting point for a gear ratio. Okay, that's 2.75. Okay, so the Mclaren F1 Gtr comes installed from factory with a 1mm offset motor pod. For that reason, I have my offset crown gear selection here ready to go. It also comes installed with a 9-tooth pinion. Let me just tell you right now that the 8 and the 9-tooth pinion are the best choices from the Slot.it catalog when it's an inline configuration, because of the way the gears are designed by Slot.it. The 10 and 11 tooth pinion will provide a horrible gear mesh. If you want to learn why, please go to austinslotcarclub.com. On the right upper corner there is a search box. Type gears pitch. First result should be gears pitch and mesh, a look into slotted variable pitch gears. You will learn anything you need to know about the slotted gears. Okay, let's continue. So 2.75, the next thing you need to do is look at your gear ratio chart and see which gear you need to use to match 2.75 with a 9-tooth pinion. Well, 924 gives me 2.67 and 925 gives me 2.78. I'm gonna go to the higher end to be on the safe side. The lower the RPM at the wheel, the more controllable the car will be. So let me find my 25 tooth gear here. There you go. By the way, all the offset crown gears from Slot.it are white. They're not color coded like the non-offset gear. So describe it on the outside or just write how many teeth are on that gear. It will make it a lot easier to find them on your parts bin. Another thing too, if you don't have a gear ratio chart, Slot Car Corner makes a very nice one. It's available for download at slotcarcorner.com. On the left side of the page there is a category box. Click on reference and you will find Slotted gear ratio reference. It's a PDF file, very well made. Okay, so let's install the motor. I'm going to get this 25 gear here in place. Okay. Alright, so to verify that we get a good RPM at the wheel, I have a spur gear fitted with a reflective tape so that my tachometer can pick up this RPM here. My power supply is still set up at 11. Let's just see what are we getting here at the wheel. Okay, it's really quick. Oh, okay, I thought it was too much. Well, 82 sounds, you know, within range of the 8,000 that we talked about. After we add the weight of the car and the wheels into the axle, it's probably going to drop down a little bit. There you go, now it's dropping down to 8,000. So that's the reason why we needed that RPM reading. Even before you get to the track, you already have a nice gear ratio already installed. Makes things a lot easier. Okay. What else? Okay, so these gears are also made out of plastic, which might get warped during the unmolding process. It's not very common on the slotted gears, but I have definitely seen some pretty warped gears from ASCC, for example. So I'm just going to show you guys here how you get rid of any imperfections on the gear. Basically what you're going to do is you're going to be spinning this gear at the same time that you're heating it up, the centrifugal force, and the mesh itself between pinion and gear should align this gear perfectly. Okay, so I'm going to turn my power supply, I'm going to turn it to a lower voltage because I don't want to put a lot of stress on this motor, so I'm running at, let's go 4, same voltage that as we did the as we broke the motor in. So let me connect my power, positive and negative here. You will need a heat gun or some source of you know, heat for this to soften that gear. What I have here is a hot air 2 made by Leicester. This one is designed to take electronic components out of boards. You don't need this guy. A heat gun with a nozzle tip should work fine. Okay. Basically, what you want to do is focus your heat in the gear itself. You don't want to be heating the motor pod or, well, the tires. I wouldn't recommend even doing this with the tires installed. So just I couldn't tell you how hot I'm running this, but the heat settings go from 1 to 6, I'm on 2, and the fan settings go from 1 to 4, and I'm also on 2, so I'm definitely not running it full blown. Let me get this guy here started. I'm also going to start this motor here. As you can see, gear spinning. I'm going to start heating up the gear, preferably pointing the hot air to a side which is not going to touch, you know, it's not going to affect the motor pod or anything else. So right now I can start to feel the vibrations coming down quite a bit. It's definitely getting hot. Yeah, the vibrations are a lot less at this point, guys. This definitely helps. And there you go. This is it. Turn this guy off. You need to leave this cooling spinning. You don't want to stop this gear right now. Just let it cool off, spinning at the same voltage we had before, 4 volts, and then turn it off and you're ready. This is it for now, guys. Until the next video.